When we look at adding and subtracting these radical expressions, we first have to simplify the radical, which is the work that we were doing. And then after the radicals are simplified, we can combine like terms. It kind of acts just like variables. So if I had a 2x plus 2x, I would get 4x. If I had a 2 square root of 5 plus 2 square root of 5, that gives me 4 square root of 5. So the radicals have to be the same in order to add them together. Just like if you had 2y plus 2x, you couldn't add those two things together. If you had 2 square roots of 7 plus 2 square roots of 5, you can't add those together. Those things, they don't go together. You have to have like terms, like radicals, in order for them to add together. So let's take a look, adding and subtracting some radical expressions here. The first one, we've got 3 square roots of 6 minus 4 square roots of 6. Well, the square roots of 6 match, so that's like 3x minus 4x. So 3 minus 4 gives me negative 1 square roots of 6. Same thing on number 3, negative 11 square roots of 21 minus 11 square roots of 21. The square root of 21 matches up. That's good to go. Negative 11 minus 11 is negative 22 square roots of 21. Let's take a look at one that doesn't match and see what we need to do in that situation. Like number 9, we've got 2 square roots of 6 minus 2 square roots of 24. At first glance, it says, well, nope, can't do that. They don't have the same exact radicals at the end. But we can go through and we can change the square root of 24. We can simplify that. And again, there's a couple different ways that we can do that. If I do some work off to the side here, the square root of 24, if I'm looking for perfect squares in there, perfect square that goes into 24 is 4. So I have 4 times 6. A nice little hint that happens here is that I'm looking to subtract this from a square root of 6. So I want to maybe try to see if I can get a square root of 6 out of it. What does 6 go into 24? How many times does that happen? And that's going to help you to kind of decide on where these, how you start this simplification problem. So I've got the square root of 4. The square root of 4 is 2. The square root of 6 is the part that it makes this thing the decimal that makes it an irrational number. So square root of 24 actually is 2 square roots of 6. So I've got 2 square root of 6 minus 2 times the 2 square roots of 6, because square root of 24 is 2 square roots of 6. 2 times the 2 square roots of 6, so I've actually have 2 square roots of 6 minus 4 square roots of 6. So now the square roots match up. 2 minus 4 gives me negative 2 square root of 6. And now that gives me the final answer. Jumping down a little bit, we'll take a look at number 13 here. Number 13, when I look at number 13, again, if you wanted to choose the other option of breaking down the radicals, you can choose that. So let's do that on this one. I've got 3 square roots of 8 plus 3 square roots of 2. A square root of 8 and a square root of 2 don't match. No good. But I can try to break down the square root to see if they will work together in a different way. So I'm going to take that square root of 8. And if I want to break down that square root of 8, I can look at it as 8 is 4 times 2. And if you knew that 4 was a perfect square, you could stop here and just rewrite it. But if you didn't, you could take the 4 and you could multiply that out or factor that out to get 2 times 2. And then we're looking at 8 is actually 2 times 2 times 2. So that means that I've got a pair of 2's that are going to come out of the radical. So the square root of 8 actually is a 2 that comes out. And this 2 that didn't have a pair has to stay inside. So the square root of 8 actually is 2 square roots of 2. So that means that I've got 3 times the square root of 8 is 2 square roots of 2 plus 3 square roots of 2 here. So 3 times 2 square root of 2 is 6 square root of 2 plus 3 square root of 2. Now the roots are exactly the same. 6 plus 3 gives me 9 square roots of 2. And that'll work just fine if you wanted to do it that way. The process becomes a little bit harder if you do not know the perfect squares, so work on learning those perfect squares. When we go to the back, the problems look like they get a little bit harder as we continue down the page, but they're really the same. The whole goal is that I want to get the radicals so that they match up. So I've got a square root of 18. Well, let's do this with trying to find perfect squares in here. So I've got 3 times the square root of 18. Well, the square root of 18, a perfect square in there, is 9 times 2. Plus 3 times the square root. A perfect square in the square root of 12, or in 12, is 4 times 3. And then we've got 2 times the square root of 27. 27, looking for a perfect square in there. We want to start at numbers that are closer to 27. Well, I know that that 4 squared is 16, 5 squared is 25. Those don't work, so I can actually go farther down. 3 squared is 9. Well, 9 goes into 27. Goes into 3 times. So now I've got 3 on the outside. I've got a square root of 9, which is 3. I've got a square root of 2, which is the non-good part of this number. Then I've got a 3, a square root of 4, which is a 2, and a square root of 3, which is the decimal portion of this answer, the part that makes it an irrational number. And I've got plus 2, the square root of 9 is 3, and the square root of 3 is the portion that I want to leave the same. Do all the multiplying. So I've got 3 times 3 here. Let me cross this out. We're going to go below it. 3 squared is 9, or 3 times 3 is 9 with the square root of 2. And then I've got 3 times 2, which is 6, square roots of 3. And I've got 2 times 3, which is also 6, square roots of 3. Now again, I look at the radicals, and the radicals don't all match up, but there's a couple of them that do. So I've got the 9 square root of 2 that doesn't match up with anything. So that's got to stay there. It doesn't get added in. 6 square root of 3 plus 6 square root of 3, though, those can be added together to give me 12 square roots of 3. A square root of 3 and a square root of 2 can't be added together, and so then that's my final answer. When you look at doing these radicals, simplify first, then see what you can add together.